Okay, hello and welcome to a express edition of Minitab for Statistics 1. So I know this is incorrect because there's no longer a Minitab tab on Blackboard. I'm not allowed to make tabs anymore. Everything's in weekly folders, but it's in the folder for your linear regression chapter. I can't remember which one it is. It's 14. Haha, words. Anyway, so today we're going to be looking at some loan application data. So this is a sample of 30 loan applicants from a bank, and we collected the following variables about them. And the whole goal of today's assignment is to try to describe what will do a good job of predicting savings. So savings is going to be our response variable, the one that we're hoping to decide what it will be, or what will cause some changes in its response. So you look at some of these possible variables to predict response, or our explanatory variables, you'll notice that there are some fairly good choices here. And I have a bird that's talking too much, so I'm going to pause. Sorry about that. Okay, so as you can see, there's quite a few variables here that you think should have an effect on savings. For instance, age. As someone gets older, usually they have more income that they can use to, save more, and or they pay off more of their debts. So of course you'll see debt down here in credit cards. Clearly these probably are going to be things that if you have a lot of, they will affect savings in a negative way, so we might anticipate a negative relationship there. Employment, if you have steady employment or you've been employed at the same job for many, many years, you might be better at saving because, reasons. Um, there's a lot here. Education, income, of course, if you have more income, it is easier to save more, so that seems to make sense. But we're going to investigate that today and try to see if there is a good thing in this data that predicts how much people can save. So we're going to start this by doing some scatter plot and some association ideas, see if we can find a relationship somewhere that does a good job of predicting savings. And then once we have a relationship, we're going to see how good our model does at predicting that and use it to do some predictions. So that's where we're at. Alrighty. So here we go. The first thing I'm going to do is number one, I'm going to create a scatter plot of income and savings and see what kind of association it might have. So there are two ways in Minitab Express you can do a scatter plot. You could go to graph. Come on. There it goes. And then choose scatter plot. Usually this is the easiest one. We want simple. We're never going to use any of the other ones in this class. You might use multiple or with groups if you take stats 2. Not even might, you will. So since I'm trying to predict what the savings is going to be, that's going to be my response. And the thing I'm using to make that prediction is my explanatory variable, the one that should explain the response. Which for us, we're going to take a look at income first of all. And that's all you got to do. Let's hit OK. Alrighty, so this is our scatter plot, which I'm going to go ahead and copy into my document. So I've highlighted it, and on my keyboard, I'm hitting the Command key and then C, which should copy it. And then I'm going to paste it over here into my document. Come on. Oh, it always wants to number everything. I'll never understand that. Word, why are you always making me mad? Anyway, so since I've got the scatter plot on one side, I'm actually going to type it on this side. Make this bigger and easier for you guys to see. Alrighty. Here we go. So it looks pretty straight. So I'm going to go ahead and call this linear. I know it's harder to judge this one since clearly me telling that bird it was bedtime didn't work. That's Divine. She's new. So we've got more data down here in the less than or around 50,000 range. So because of that, don't be fooled into thinking that, I have a weird relationship where I've got like kind of this weird curvy line here and up there. You need to consider all the data. So just because I have more data down here, don't let that hide your picture. So this is kind of a cylinder, pretty straight. These two might be outliers. This is not an outlier because it's on pattern with what the rest of the data is doing. So I'm going to go ahead and call this linear. However, I do have some scatter. So this is probably a moderate or a strong. I'm going to call it strongly moderate so I can commit to nothing. Oops, I missed the R. I did that in the notes too. That's so bad. The other thing I mentioned in the notes is that, really correlation is going to give us a better picture of how strong the relationship is. What's important though is you aren't seeing a weak relationship or one you think that you shouldn't bother trying to model because it's so weak. So it looks like there's something going on here. There's some sort of relationship. Okay, I'm going to go ahead and say this has no outliers. I know those two up top are a little tempting, but they're also close to each other, so it's probably true that they're not outliers. All right. And then last but not least, let's see, I got form, I've got strength, and I've got outliers. Ah, I'm missing the D, the direction. This looks pretty positive to me. Just to take you through positive one last time. So if you start somewhere in the if you start somewhere in your data and move positively in the x direction, so positively in the x direction is to the right horizontally, whatever direction you have to head to reach back to your data, if it also happens to be positive, makes this an overall positive relationship. If it's negative, then it would be a negative relationship. So since I have to go up, which is positive in the horizontal direction, in the vertical direction, this would be considered a positive relationship because I had to move positive, positive. If one of them was the opposite, so as if one of the directions I had to move was positive and the other was negative, then this would be a negative relationship because remember, we think of negative relationships as opposites. All right, let's calculate some correlation. Woohoo! So this is fairly easy to get. There's two ways you can do it. So if I click in here, if we go to statistics and then summary statistics, nope. Where is this? Correlation. Here it is. Okay, so there's two ways you could do this. The easiest one probably is to go to statistics and then down to regression, and you'll see an option at the top for correlation. And we're just going to throw income and savings in there. We are doing the Pearson correlation. A couple things to note about this is you notice I put it in income then savings. Order doesn't matter at all here. I mentioned about this in the video. Since it's just measuring the strength of the relationship, it doesn't matter to correlation who's X and who's Y. It will matter when you're doing linear regression, but for correlation, it's just trying to say, are these related or not? Let's go ahead and do that. So it appears that my correlation, which is the only thing I care about here, so it's the only thing I'm going to write. My R is 0.874282. So, and it doesn't matter if you use capital or lowercase r. Traditionally we use lowercase, but it means the same thing. So what this is telling me is I do have a fairly strong, because it's close to 1. -1 is also close, but the fact that it's positive tells me, hey, my direction is positive. So it seems to match what I was seeing on the scatter plot and my association. So remember, when you're looking at correlation, it measures strength of linear relationship and really only tells you information about how strong it was and how positive it was. And you really should not do it if you don't have linear to begin with, which is why you should always do the scatter plot first. All right, let's take a look at making a correlation table. So I'm going to do the same thing, but I'm going to do it to a bunch of different variables, because you might look at this and be like, okay, that one's strong, but is there a better one? Would, maybe your debt be a better predictor of what you can save or not, or your age? Let's find out. Make similar. So this is just going to correlation again, and I'm going to add in some stuff. So I want to add in age, and where's debt? There it is. And then credit cards, to see if one of these maybe is a better predictor of savings. And this is going to produce what's called a correlation table. And this is a little bit difficult to read, and that's why we're going to go over it. Alrighty, let's go ahead and copy our table over. And then I'm going to make it a little bit bigger so it's easier for you guys to see on screen. Well, it's already pretty big on Word as it zooms it in. That's good. Okay, so how we read this is a little difficult, but this entry right here, this is in the box that goes with, actually, hold on, let me change this a little. If I can change this table to have all the borders, then it might be easier to see what's going on. Yep, okay, cool. So we're going to ignore the second line, so this second row here for savings, this second row for age, this second row for debt, second row for credit cards. You don't need those in Stat 1. We talk about them in Stat 2 and what they mean, but for now you can just go ahead and ignore them. So what you want to pay attention to is values like right here. So you should recognize this value as the correlation between income and savings. So this is the correlation for income and savings. So whatever row and column it is the two that it's correlating. So for instance, this correlation is between savings and age. So what's weird about this is savings has 2 columns in here, but there isn't a box for when I compare savings with savings, because that would be a perfect relationship. Yeah, if I'm trying to correlate something with itself, of course it's going to be perfect. And it's also not going to tell you anything because, well, how can I use something to predict itself? That's just silly. Alrighty. So take a look at this table. Who's the weakest correlation? I'm trying to give you time to think. Oh, hey, it's age and debt, because this is the one that's closest to 0. Don't make the mistake of thinking, oh, negatives are bad. That's the weaker relationships. That's absolutely not true. Remember, negative just means it's a negative direction. That's all. It doesn't tell you anything about like anything else, really. Negative, positive just gives you direction. And then closer to one or negative one is going to be the stronger relationship. So remember what we want is farther from zero. The closer to zero, the weaker it is. So 0.14 is weaker than 0.58 and is weaker than negative 0.53. So age and debt would be actually the weakest, which is interesting. But when it comes to looking at savings, because that's what I'm trying to predict, it looks like income is the best because here's the correlation for it in savings. Here's savings with age. Here's savings with debt. And here's savings with credit card. Clearly, debt and credit card are negative relationships. So that's not a shocker. But income seems to be the best. So we're going to go ahead and do this with income. Alrighty. Next up. Oh, I wanted this to fit on one page, but there's no backspace button in Max. So that's awesome. All right. We'll do number 4 for fun. Not for fun, because, well, I don't know what I'm doing anywhere. Anyway, so how much variation in savings can be explained using credit cards? So what this really is asking you about is, hey, what is the value of, hold on a second. Once again, Divine doesn't want to be quiet. Okay, so I want to say how much variation in savings can be explained by using credit cards. So what I want to look at is how much variation is explained. That's the same as asking what's the value of r squared. So to find r squared, you just need to square r. So savings with credit cards is right here. So I'm going to take this value and I'm just going to square it. Let's write that a little bit clearer. So r squared is, just going to take the r value, negative 0.413043, and then square it. When you do that, you get 0.1706. So not good. So you remember we interpret this as a percentage, so it's about 17%. Actually, that's too much rounding. Let's do 17.06. So about a little over 17% of savings can be explained by how much credit cards, somebody has. That's not good. Clearly, credit cards is going to do a poor job of trying to explain savings. So you should really look at something else, which is why going forward, we're going to be using income since it was the best predictor and had the highest r squared, highest r value. It likely is going to do a better job. We'll interpret its r squared value later. Moving on. Let's go ahead and calculate the linear regression equation, also known as the line of best fit, for income versus savings. So I'm going to show you 2 ways to do this on Minitab. So there's 2 buttons you can get to that gives you the same thing. You can hit this regression button and ask it for simple regression. Notice correlation is there as well. Or if you saw where I was going with correlation, you can, where I was going when I was doing the correlation button when I was doing the correlation calculation. I cannot talk today. We go to statistics and then to, oh my gosh, come on, where is it? Regression, correlation. My mouse is acting up. I bet I have to charge it. So right there is simple regression as well. So if you're one person who likes the buttons more than the menus, here we go. Simple regression. This is one of many ways you can do regression on Minitab Express. There's a couple different other ways you can do it. I like this one because it's the simplest. If you would like to use a different one, or if you watch other videos about how to use Minitab Express, you may see some other ones. Again, there's just lots of ways to do this. In particular, I like the fact that it labels your X and Y for you, which if you forgot what the names of them are for response and predictor, this helps. So the response I'm trying to make my predictions about is savings, and then what I'm going to use to do it is income. Now, I'm going to mess with the rest of these options later. For now, we're just going to focus on making the line and then using it to make a prediction. And then we'll change up some of this stuff later. Da-da-da-da. All right. So the only thing I needed to finish number 5 was this equation. So I'm just going to go ahead and copy it, paste it in, and call it done. Except for I'm having a hard time pasting. There we go. So just needed this equation right here. Whoops. I wanted to copy this part because I'm going to need it for number 6. I'm going to put number 6 on the next page. Come on, you. All right, so that was it for number 5. Let me make that red so it's clear that that's not part of a question. Alrighty, does this be it? I'm going to use this. Helvetica. Do, 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 do. All right, so using the line of best fit, 4, 2. Wow, that's terrible. Yep, to predict savings of somebody who made $72,000. So I'm saying I know their income. Let's figure out what their savings would be using this line. So I'm just going to replace income with, well, what their income was. 72,000. Lady Divine, you need to behave yourself. I don't know if you guys can hear her. I'm going to listen back to this, and if she's really rowdy, I'm going to try to tune her out. Alright, so what I'm doing right now is I'm going into my calculator, I'm multiplying 72,000 by 0.27567 and then adding to it the negative 7,828. And when you do that, you get $12,020. Remember, this is money, and 24 cents. Oh no! I just realized that I have a typo in the other video. I suck. Okay, so that's what my line predicts somebody should save if they make 72,000. Now, looking on to number 7, you'll notice, hey, is that actually what they actually saved? Let's find out. Let's calculate the residual. So just as a reminder, your residual is the actual data value minus, yeah, I didn't think I spelled that right. There we go. The value that you predicted using the line. So for us, I already have the prediction. I just did that. That's that 12, 20, 24. And the actual value I have to get from the data. So I'm going to go over here and find somebody who made 72,000. Oh, look, it's the second row. I maybe picked that on purpose. So that was their income. What was their actual savings? It's 12,000. So that's what I'm going to be looking at. So I'm going to subtract those two from each other. I tried to pick something that would be easy for you to tell if you got it right. You should get negative $20.40. I should be labeling this as money though. Or sorry, 24 cents. Awesome. Mathing. Okay, so we're off by about 20 bucks. That's not bad. Not bad at all. In fact, that's pretty good. So be careful though. Looking at one point when you have 30 and saying that it's good is probably not a good plan. So because of that, we're going to look at some other possibilities here. So we're going to go back to our line of best fit and ask it to store for us the residuals. So one way you can get around this is I want to make all the predictions. So I want to do this, what I did in number 6, for every value of income in C1. So let's do that. So we want to go to data. Where's formula? Formula. And so I'm going to use my equation. Negative 7,828 plus, oh, I have to be careful. Minitab is very particular about you using its key code for this. I want to do 0.2, so notice I'm typing on their thing, not doing it on my keyboard because it's pretty picky about that. Times my income variable. So what this is going to do is it's going to create a new column right here. That's all the predicteds. Got it? Oh yeah. So I'm going to rename this. These would be the fits. Perfect. And then I'm going to do all my residuals. So I'm going to go back to data, formula. All right, so what I want to do is I want to create my residuals. So that's going to be my actual values, my actual savings, this column, minus the prediction I just made from savings using the line, which was what I made in C9. So I got to do savings, oops, come on, get in there, minus fits. And it should put that in my last column here. Although I've got it highlighted, so it might put it next to it. You don't have to highlight anything to do this in Minitab. Express. Perfect. Looking good. All right, so this would be my residuals. And just to check ourselves to make sure we got this right, look at row number 2. Yeah, That matches our number 6 and our number 7. So looking at residuals, you should say, ooh, maybe my model ain't so good. Because here I'm off by like $6,000. That's not great. Here I'm off by 7,000. Yikes. There are a couple where I'm doing pretty good, by like off by like 75. But there are some where I'm doing real bad with my prediction. Eesh. Okay. Let's graph these residuals to see whether or not we fit everything that we're supposed to for this. So to do that, I'm going to go back to regression, simple regression, and I'm still going to be predicting savings using income, but I'm asked Minitab to produce some graphs for me. So I'm going to click this because I can't select which ones I want to do. It is what it is. One of these I'm not going to use. This is the versus order graph, and I'll explain to you why when you see it. And then we're just going to hit OK. Da-da-da-da. Where's my graphs? Oh, they're at the end. I always forget that. It prints this off so weird. So this is the versus order graph. If your data has order to it, or order matters, like if it's depends on time, then you want to pay attention to this graph and how it looks spread. Ours has nothing to do with time or order, so really this isn't something that I care about. What I do care about later. Yes, please update in the middle of my video. What I do care about are things like this. This is the normal probability plot. It and the histogram are how I'm going to decide if this looks nearly normal. So since all of my points, except for like a couple, are really close to my red line, this looks really, really normal because the red line represents what perfectly normal would look like if it was graphed straightly, because it's linear. And then you look at your histogram, and what you're looking for is nearly normal. Does this look like the normal distribution at all? And it just has to be nearly, which means it only has to have one of the 3 characteristics the normal distribution has. This is why you had a discussion board on what those 3 characteristics are, and that didn't go so well. So you want to look for, does it have a bell shape? Is it unimodal? Is it symmetric? And as you can look at this, clearly it's not bell-shaped, not symmetric, but it is unimodal, and it really only needs one for it to be nearly normal. So this one's going to pass. But even more so, it's definitely going to pass because looking at this, the points are fairly close to this straight line, which tells you it looks normal. Okay, the next thing we want to look for is it equally spread? Actually, you know what? Let me copy this graph over and say that, because it's going to be better if we type this. So unfortunately, you're going to watch me type the thing I just said. It'll be okay, though. Because then you'll know when you do your assignment that you have to type your answer in, rather than just copying a graph and assuming I know what you meant. So I'm going to say this is nearly normal, since the points, sorry, I'm not going to say since the points, I'm going to say the majority of the points, because it's all of them but 2. Are close to the line. Alternatively, you could look at the histogram and say, hey, this guy looks nearly normal because blump, because it's unimodal. Since the histogram is unimodal. Oof. The residuals are nearly normal. Perfect. Okay. So again, you only really had to do one of those, either use the histogram or the normal probability plot, but I did both just so you could have options in case when you look at that normal probability plot, it scares you. You also have the option of looking at the histogram. Or if one of them it doesn't seem clear enough, you always could look at the other as well. I usually look at both before making my decision. All right, next up we want to look at the versus fit graph. Let's go ahead and copy it and paste it into our document. I put this in the wrong one. This should be in number 9, and I put it in number 8. Darn it. We'll just take number 9, copy it, and move it upward. I am making all kinds of mistakes. I'm going to blame it on that bird. She distracted me. There. Now I have number 9 in the right spot. Sorry. The only way I'm going to see number 8 is by looking at your data, so make sure you're sending your data this week. All right. Versus fits. So I don't know if you remember this, but what we're looking for here is no pattern whatsoever, because that means I systematically did not miss anything when it comes to making my model, which meant my model was sufficient. Now, looking at this, I see a very clear sort of like cone-ish pattern here, which is not good. That tells me that my model was really accurate for the small values of data, those below 5,000, and then it just got worse over time, or sorry, over values, which means that as I increased in value, my model got really bad, and that's not a good thing. So the first thing we do is we check equally spread. So this is equally spread because I have about, we never use first person, what am I doing? We have about the same number of points above and below 0. Ready? Here's the bad part. However, this is still not a good model because there is a cone pattern. That's not how you spell cone in the residual graph, which is unfortunate because that means that you missed something in your model, and there's definitely something missing. For those of you who are interested, if you add in at least one other variable, and I can't remember which one it is, I think it's debt, you get a nearly perfect model, which is good. So what this is really saying is one variable isn't enough. I needed another one to account for what could be going on. Oops, accidentally hit delete. So just so you're aware, if you're interested in multilinear models, go ahead and take stats 2 because that's when you'll address them. We don't do them in this class, so just to keep in mind, like, the world is bigger than what we do. All right, let's find the value of r squared and interpret what it means. So there are a couple places you can find r squared. You could go back to our correlation table, grab r and then square it like we did in number 4. Or you can just scroll up until you see the model summary. So there's my model summary with my r squared value, 76.44%, which is actually pretty darn good as far as correlation, ratio variation values go, aka r squared. So our r squared, I'm going to type it like Minitab does. R squared is 76.44%. Then we write what it means. So we use r squared as a ratio of accuracy of how accurate our model is at making predictions about the response variable, specifically changes in it, because what we want to do is we want to be able to model change. As we look at changing our input variable, how much is it going to change in response, and how accurate is that change by that prediction. So in this case, only 76.44%. We're going to write this in a fairly simple manner. About 76.44% of the variation seen in savings can be explained by the linear relationship with income. So I've capitalized the variables to help you spot them, but basically this is always what's happening. How much was my line able to explain about how these two are related? About 76.44%. So clearly savings has something else going on, which our residual graph indicated to us that, income wasn't able to explain. So adding in another variable would probably help this out, but we are not going to do that. We're only going to focus on doing the simple linear version of this. So that's it. Yeah, good times. R squared never means anything else other than this. So it's kind of formulatic. It's always the same. About this much of the variation seen in my response can be explained by the linear relationship in my explanatory variable. However, if you write anything other than what the variables are, it just looks like you're a robot. Yeah. And the closer to 100%, the better this is. Close to 0% means your model told you nothing, so that's bad. We'd like to keep these around about 80% when it comes to making realistic predictions. So this isn't a great model. We clearly need some more. If you're just looking to make a quick estimate and don't really care about how accurate it is, as long as you're above 50%, you're probably okay. Keeping in mind, though, that, your model ain't that great and you probably could do better, that kind of stuff. If you ever see anybody doing stuff with data and they get 100%, boy, are they lying to you, because that'll never happen with real data. You should be very suspicious of anybody who presents their results to you and they've got 100% r squared. Just saying. You know, look out for the shylarks, that kind of thing. Shylark a bad word? I don't know. I should probably look that up.